So what if the answer to AI's biggest problem on Earth isn't actually on Earth at all? I mean, what if we could just launch the whole computational heart of AI into orbit and power it directly with the sun? It sounds like science fiction, but let's dive into what might be one of the boldest industrial plays in human history.
It really all kicks off with a number that's almost impossible to wrap your head around: $1.25 trillion. That's the rumored valuation of the new company that's being created by merging SpaceX and Elon Musk's AI venture, xAI. You see, this isn't just some corporate merger. This is the war chest for an absolutely radical new vision.
And there it is, the vision in a single sentence. The goal is to physically move AI's core infrastructure, we're talking the data centers, the processors, the whole shebang, off the planet and into low Earth orbit. But why? Why would you go to such an incredible, almost absurd extreme?
All right, so let's break down this trillion-dollar bet. It's called the Space AI Plan. And you need to understand, this isn't just some cool project. It's a direct and maybe desperate response to a crisis that's building up really, really fast, right here on the ground.
This quote right here gets to the heart of it. This whole thing isn't about doing cool stuff in space just for the fun of it. It's about solving a massive bottleneck that seriously threatens to stop the AI revolution in its tracks. And that bottleneck is energy.
So what is this crisis, this Earth's bottleneck? Well, to put it simply, AI is getting so powerful, so fast, that its hunger for electricity is growing at a rate our planet's power grids just can't keep up with. And just look at this trajectory. It's staggering. In 2024, data centers are already eating up a massive 415 terawatt-hours of power. But the forecast for 2030? It more than doubles to 1,000. Places like Silicon Valley, their grids are already maxed out. We are literally hitting a physical wall.
And this is where the orbital plan starts to make a wild kind of sense. Here on Earth, our best renewable energy is intermittent, right? The sun goes down, the wind stops, you have fights over land use, and you need incredible amounts of water for cooling. But in space, you get sunlight 24/7, no clouds, no night. That makes solar panels something like 5 times more efficient. And the best part? The vacuum of space is your cooling system.
So, that's the why. Now for the really interesting part, the how. How do you actually build a data center in space? Well, the answer lies in this incredible vertically integrated system that Musk has been building piece by piece for over a decade.
It's like a 3-part engine, and each part is crucial. You have SpaceX, which provides the cheap and reliable rockets to get everything up there, plus the Starlink constellation for global connectivity. Then you have xAI, providing the actual AI models like Grok that will be the brains of the system. And finally, you have Tesla, bringing its world-class expertise in battery systems, solar, and even custom AI chips. It's a closed loop.
Now, don't picture a few giant space stations. The plan is for a massive, distributed network. We're talking about a constellation of up to 1 million satellites. But here's the key. They're not just for beaming internet down. They're being designed as powerful computing nodes themselves, turning the entire network into a giant, orbiting supercomputer. And its main job? Running AI inference. That's the part where you actually use the AI, like when you ask a chatbot a question and it generates an answer.
And believe me, this has been thought through in incredible detail. They're planning to fly these satellites in shells between 500 and 2,000 kilometers up. That's kind of the sweet spot to get a good signal delay without getting fried by too much radiation. And they'll use what's called a Sun-Synchronous Orbit, which basically means the satellites are always in the sun, always generating power. And to link them all together, a high-speed mesh network using lasers. It's a data fabric in the sky.
Now, it's so important to understand that none of this would even be remotely possible without 2 absolute game-changing technologies. First, the fully reusable Starship, which promises to drive launch costs down to a target of just $15 a kilogram. That's just insane. And second, the next-gen Starlink V3 satellites, which are being designed with powerful processors built right into them from the start.
Okay, but as cool and elegant as this all sounds, it runs headfirst into some huge challenges. We're talking about a real fundamental test of physics. Let's get into the 2 biggest engineering hurdles they have to clear for any of this to work.
Number 1, and this is a big one, is heat. AI chips get incredibly hot. Here on Earth, we just use fans and water cooling systems to carry that heat away. Easy. But in the vacuum of space, there's no air to blow, there's no water to pump. So how on earth do you stop your billion-dollar computer from melting?
Well, there's only one way: thermal radiation. An object has to literally glow with heat, radiating it away as infrared light. The problem is, this is way, way less efficient than the cooling we use on Earth. The only way to make it work is to have massive radiator panels, kind of like giant wings on every single satellite, all pointed away from the sun and into the freezing cold of deep space. The second massive challenge is radiation. Space is just filled with these tiny, high-energy particles, cosmic rays, zipping around. And if one of those hits a computer chip in the wrong spot, it can corrupt data, cause a crash, or even physically destroy the chip. Now, the old-school NASA way to solve this was to build these custom, super expensive, and frankly slow, rad-hardened chips. But that's not SpaceX's philosophy. Their plan is to use cheap, off-the-shelf commercial chips, the kind you have in your computer, and then solve the problem with smart software. You have multiple chips running the same calculation, and they vote on the right answer. If one satellite gets zapped and fails, the network just routes around it. It's achieving reliability through massive numbers and redundancy.
So, let's say they can actually solve these insane physics problems. What's the end game here? Because this isn't really about building a faster data center. For Musk, this is an interstellar prologue. It's the foundational first step in a much, much bigger story for humanity.
To really get the scale of the ambition here, you have to know about something called the Kardashev scale. A Type 2 civilization is a hypothetical one that can harness all the energy of its star. This plan, to capture pure solar energy in space and convert it directly into computation, into intelligence, is being framed as humanity's very first tiny step up that cosmic ladder. This orbital AI network is seen as the key that unlocks everything else. The goal is to create a future where energy and computation are nearly free and abundant. That would give us the industrial power to start manufacturing things on the moon, and that, in turn, provides the infrastructure, the communications and data backbone that you'd absolutely need for a self-sustaining city on Mars. It's all about making humanity multiplanetary.
So at the end of the day, we're left with this massive question. Is this the necessary, logical next step for our civilization to grow beyond this planet, or is it just one of the most colossally complex and expensive gambles in human history? The physics are truly daunting, but the payoff? Well, the payoff could literally redefine what it means to be human.